How about chemical evidence, though? What produced all this molten metal? And what is thermite anyway?
Thermite. An incendiary used by the military, thermite is a compound of iron oxide and aluminum, which when ignited sustains an extreme heat reaction, creating molten iron. In just 2 seconds, thermite can reach temperatures over 4,500 degrees Fahrenheit, quite enough to liquefy steel. We know that open-air fires cannot burn hot enough to melt steel, but metal had melted at the base of the towers. Appendix C of the FEMA report describes sulfur residues on the World Trade Center steel. The New York Times called this the deepest mystery of all. Sulfur slightly lowers the melting point of iron, and iron oxide and iron sulfide had formed on the surface of the structural steel. Sulfur used with thermite is called thermate, producing even faster results.
NFPA 921 is the guide for fire and explosion investigations. Was it used? They say unusual residues could arise from thermite, magnesium, or other pyrotechnic materials. In a crime scene, which this was an example of, did NIST use the guide? No. They acknowledged they didn't even look for such evidence. But others did. Dr. Stephen Jones performed chemical analysis on the previously molten metal. He does some background research, again part of the scientific method. Thermite would create a characteristic burn pattern with a white ash, a white-yellow hot liquid metal, an intense white reaction zone seen. It would also leave behind chemical evidence. Common elements such as iron, aluminum, copper, calcium, silicon. Unusual elements such as fluorine and manganese left behind also in their residue. These elements here. He sent a sample from this 40-pound chunk of previously molten metal from one of those meteorites. He finds that it's predominantly iron, so we can rule out aluminum from the jet plane. It has small amounts of aluminum, sulfur, and potassium, and manganese and fluorine in abundance. Manganese is from the potassium permanganate, commonly used as an oxidizer in thermite. Fluorine is also used in sol-gel-type thermite charges. So these appear to be the thermite fingerprint. Let's take a look at what else Dr. Jones found in the slag from the end of this memorial at Clarkston University. He performs his X-ray fluorescence on this small piece of slag and finds, once again, iron, sulfur, potassium, manganese, calcium. Gel explosives are all a super thermite, tiny aluminum particles in iron oxide in this sol gel. They can be cast into shape. They're like a clay. Lawrence Livermore Lab did research on this, and this invention offers a thermite-based apparatus for cutting target materials. You pack the thermite in here, and you ignite it, and it comes out and is forced through melting the structural steel element in fractions of a second, almost as effective as high-energy explosives, RDX and C4, which are more common in classic controlled demolitions. If sol gels were used, they would leave behind a very unique signature, 1,3-diphenyl propane. And in fact, EPA finds one molecule in their toxicological studies at levels that dwarfed all others, 1,3-diphenyl propane. Eric Schwartz says we've never observed it in any other sampling we've ever done. But is there evidence of thermite in the World Trade Center dust? Dr. Jones received no less than 4 separate samples of World Trade Center dust, some of it from an apartment across the street, Jeanette McKinley's apartment, where the windows blew in and filled her apartment with a foot of this dust. Another sample was found like 10 minutes later on the Brooklyn Bridge. Well, he takes this and he puts a magnet over it, and he finds that there are small particles that come up to the magnet. Some of them are angular. Some of them are round. They look like this. In fact, he calculates by the weight of the amount of these spheres that he finds in the dust that there must have been about 10 tons for all of the dust that was available. They're about a 1/16 of an inch in diameter, the largest ones, and most of them, though, are smaller than a human hair. What could produce such an incredible array of microspheres? Well, if you had thousands of cutter charges going off in the columns and beams throughout the building, and they were under this incredible pressure, what you'd see is something like this. Tens of thousands or millions of tiny droplets. What's the shape of those droplets? When a liquid is dispersed like this, its surface tension forms itself into almost a perfect sphere. In the case of molten iron, those droplets cool and they fall along with the dust everywhere. He compares the spheres to a known thermite experiment performed by John Peroulis in Nevada, which finds the same spheres. In fact, we do another XEDS, and we find in the microspheres the same kinds of evidence. We have iron, manganese, and in the case of this known thermite signature, it matches basically. In other words, we have a controlled experiment to compare the results against. And for those who know how to read these graphs, such as Dr. Jones and others, this is pretty much of a direct match indicating that this is the signature of thermite. Dr. Jones is not the only one who finds these iron-rich microspheres. The EPA finds them in all the dust and the toxicological studies they're doing. They have no idea where they came from. They don't report the results other than just a tiny bit. They're curious. They sweep it under the rug. It has only one possible formation, and that is from liquid molten iron under extreme pressure. R.J. Lee finds the iron-rich microspheres on top of the Deutsche Bank building in their toxicological studies. Is this what corroded the tops of these cars? This atomized thermite, cooling. Manganese was also found in large proportions, very toxic stuff from the city's chief medical examiner. Very, very concerned about it. Well, Dr. Jones concludes that given the mix of trace metals present in these high concentrations in the dust, such as zinc, copper, manganese, and the formation of iron-rich aluminum spheres, it's clear that significant aluminothermic reactions occur, and he can reverse engineer this and suggest to us that there must have been in the thermite mix powders of aluminum, iron oxide, copper oxide, zinc nitrate, and potassium permanganate. Well, would there possibly be any unignited thermite pieces in the World Trade Center dust? Indeed, he finds it. It also comes up to the magnet from his dust samples. Many chips. This one, a 1/16 of an inch long, red on one side, gray on the other. The red side is composed of tiny iron oxide particles and aluminum. In fact, he does an XEDS on this stuff too. And he finds a little bit of sulfur, more aluminum, lots of iron, and manganese. And compare that to the traditional thermite. It's also a match for unignited thermite. This stuff is not made in a cave in Afghanistan. The Lawrence Livermore Lab came out with papers only a year or two ago about this stuff. The particles being so small allow for almost instantaneous ignition between the two chemicals, the aluminum and the iron oxide, producing very explosive results. Los Alamos Lab and Lawrence Livermore Lab have produced these results. Then he continues his study and finds additional chips that are partially ignited with spheres embedded in them, indicating that the source of the spheres is, for all intents and purposes, identified very clearly here. Partially reactive thermite.